Hello, welcome to Functional Bar. My name is Charles, and in today's video, we're going to be talking about Hello World, our first program. Hello World has a special place in my heart. It's the first program that I learned to write, and so I'm teaching it to you as well. But not only is it the first program I learned to write, but also the first program I write in every language that I'm learning. It's an excellent tool just for basic project setup, even after you are an accomplished software engineer. So today, in that vein, we're going to be talking about project setup. So we're going to talk about the tools we're going to be using. We're going to install those tools. We're going to make a project. We're going to use one of those tools to make a project for us. We're going to run it. We're going to change it. That tool we use will generate some files. We're going to change those to be what we want them to be. We're going to give an overview of what those files are. We're going to have an overview of what's in the file, what every line in that file we edited means in our first program, in our first file of source code, everything that means. And then that's going to be that for the video. So remember, the focus here is on getting things to compile for the simplest program we can write, or one of the simplest programs we can write, and not so much learning a whole lot about what the source code means there. It's really just like, let's get this first step taken, and then we can start digging in further. So without further ado, let's go ahead and get started. The tools we're going to be using throughout these videos, throughout the Haskell videos, are GHC up. That's how we're going to install the Haskell compiler and associated tools. There are a few tools that go along with it we're going to be using. Those will all be installed with GHC up. GHC is the Glasgow Haskell compiler. It's probably the best known Haskell compiler. It's not the only Haskell compiler. There are several Haskell compilers out there. Different projects may use different compilers for different reasons. We're going to be using GHC. We're also going to be using Stack as our project management tool. There are competitors to Stack. And so if you're digging around on the internet, you may see Cabal, you may see Nix. We're going to be using Stack. It's completely possible for you to use these other tools, but I'm not going to be discussing how to use them in these videos. I'm only going to be discussing how to use Stack. So how do we get GHC and Stack installed? Well, we go to, got my windows open, GHC up. You can type into whatever search engine you prefer, GHCUP, GHC up, and hit enter. That stands for GHC update, I believe. You want the one from Haskell.org. Now this does work on Windows, but for those of you with sharp eyes, you'll see this particular one only works for Linux, Mac, FreeBSD, or WSL2. If you're using Windows, this should tell you how to use it, how to install it for Windows. There's a PowerShell script you run. You can also click on installation and come down to the for Windows, please run this in a PowerShell. But that first page should have what to do if you're on Windows. So you can run it just fine on Windows as well. Then we just copy this line out. Curl is the program it's going to use. You've probably already got that installed. If you don't, just install it with whatever package manager you have. I already have this installed, so you may see warnings about, hey, you've already got it installed, what are you doing, etc. But it doesn't hurt to install it again. And so I'm just going to run you through it. So you see, it's going to tell us what it's installing: GHC up, GHC, Cabal, Stack, HLS. The Haskell HLS is the Haskell language server. Many editors are going to depend on that to do proper syntax highlighting. So I'm going to recommend everyone install it, especially if you're still trying to figure out which editors you really like. If you already know you don't need it, then you don't have to install it. So you'd hit enter to continue and Control-C to abort. So we're going to hit enter. Yes, we want to prepend this to our shell, and that's the default. So I'm going to type a capital P. You may have some different verbiage here depending on what system you're on. It may be R shell or C shell or Z shell or your command.com, whichever. But we want P for prepend to the path. Do you want to install the Haskell language server? The default here is no, but we're going to do something different. I'm going to recommend everyone press Y, and that's capital Y, and hit enter to install it. Then say, do we want to enable better integration of Stack with GHC up? Yes, we want that. That is a default. We hit Y. Now it's going to give us a warning that you may have to have other software installed. So what I would recommend you do is maybe take note of this and go ahead and hit enter to see if something dies. If it dies while it's trying to build something, you might scroll back up to this message or run the program again and grab these files and install them using your package manager. And by that, I mean like apt if you're on a Debian system, apt, brew if you're on a Mac OS. On Windows, it's going to be completely different. I don't recall what I had to install there. So it was, you maybe don't have to install anything. I just don't remember, but it'll tell you what to install if you need to install something else. So go ahead and hit enter. This may take a little while. This may not take, if this is your first time, it will take a little while. It's going to download a compiler and build it. It's going to download and build GHC up, etc. Like I said a minute ago, have already installed this, so it was pretty fast. I want to call out something. This is all done. Here's some things you can do right now. What I want to call out first, though, is in red up here. You have to restart your terminal for the changes to take effect. That's really important. It tells you can run something else. I like to restart it. So I just type exit and enter. Now, if you're on a Mac, you're going to have to hit that X sign. Relaunch our terminal here and resize my screen. So my terminal's back open and I can type GHCUP space TUI. Text User Interface is what TUI stands for. And we can see that it's got a bunch of stuff here. How you read this is if it has a single check mark, it is installed. If you have a double check mark, it is installed and the default that's going to be used. This is especially important with things like GHC, where we need different GHC versions for different projects, potentially need different GHC versions for different projects. And Stack manages that for us for the most part. And well, in fact, with that integration, we said, yes, we want the integration, was to let Stack have GHC up install different versions of the GHC, so Stack doesn't do it in each project folder. We get out of this by pressing Q. And so that's it for the installation. It should be relatively painless and reasonably fast. You may have to wait a little while it's downloading and building. So now let's learn how to make a new project. First, I'm going to go into my source directory. And if you are new to this and you watch the preliminaries with the command prompt basics, we made a source directory there. So you should already have one. You just cd to source. And now to make the new project, it's stack space new space project name. And our project is Hello World with a dash. That dash is important. It's how we separate words when we're making projects with Stack. You may see some other stuff happen here. This is normal. I haven't set any of these variables. I don't need to. I'm not making projects here to publish. You aren't making projects to publish right now, so that's fine. You can go configure it later if you want, but you don't need to change anything here right now at all. And if you do want to change stuff, you can edit it directly in the files that Stack has generated for us later. So now we see that hello-world has been made. And here it is right here in my list. So we can just cd into hello world. And you see Stack created a whole bunch of stuff for us. Right after it makes a project, it's going to run. So let's run it real fast. We run the project with Stack. We run the project with stack space run. And then we hit enter. And you see it printed some gibberish to the screen. I try to pay attention to this so that I know what it looks like, what good output looks like. It's just compiling stuff. We see, hey, I'm compiling all these things. It's like, okay, I know what good compiler output looks like. I know what to expect. If something goes really weird there, then I know something's off or unexpected, and I maybe need to pay more attention to things. This last line here is what the default program does for Stack. And that's fine. It's just what we expect for the very first And when we make a new stack project, it's always going to say this, and that's fine. That's what we expect. It's not what we want. We're going to be changing that here in a little bit, but that's what we expect right now. And this is something endemic to software engineering. We take a tiny step and it's not right, and that's fine. We're going to make it closer to what we want later on the next iteration. So you often hear people call it an iterative process. So we start with something kind of close and then make it closer. So let's look at what Stack has generated for us. Now I am going to give you a brief overview of all these files, because when I'm learning something, I appreciate the overview, even if I don't understand it, even if I'm like, I don't have any clue what this means, but now I kind of know because he gave me some words and I can look it up a little bit later. The only thing you have to remember from this, the only thing I want you to remember from all of these files, what all of them do, is that app is a directory with main in it. And I'm going to say that again. App is a directory with main in it. So we edit our source files in app. That's the only thing you have to remember out of all of this. The rest of the stuff I'm going to talk about is informative, just so you have some kind of idea of what's going on. The file here, changelog.md, historically, that's where we keep a changelog. Like a long time ago, we'd go right into these files, what we did, and save it there. It might be on a shared drive even, heaven forbid. But we have had source control systems for a long time in some iteration or another, some version or another. Now the preference is not so much to use a changelog as it is to use proper log statements or proper messages, commit messages in the source control system. That changes based on shop. Some shops are really going to want to changelog. Some projects are really going to want to changelog. So just pay attention to where you are. For us, there's no need for you to write a changelog unless you want to. Helloworld.cabal, this is generated for us by Stack. Stack uses Cabal under the hood, so we can safely ignore this. We don't have to know anything else about it. You can look at it if you want, but it's going to be overwritten the next time Stack runs, or you might get an error message about how they don't match or something. License is your software license file. For these toy projects, you don't need to worry about this at all. If you're going to put it up on a public repo, you probably ought to put it under a correct license. These toy projects, these sample projects, these learning projects, it's not going to be a big deal either way. So it's not like it's going to hurt you, but you may want to start looking at what open source licenses you like if you're making the source code public. And I say open source because if the source code is public, it's an open source project at that point, kind of by default. Package.yaml, this is where we're going to specify our dependencies. It's already stubbed out for us. It already has the basic libraries we're going to need in there, so we're not going to touch that for a while. It is a file that we will be editing when we need to. When we get to the point where I need to start pulling in other libraries, we're going to start editing this file. readme.md on a real project. This is absolutely critical. On a real project where other people are using it, this is critical. You generally want to put build instructions in there, like how do you build the program? How do you run the program? How are other developers going to interact with it? Especially how are other developers going to interact with it? It is occasionally targeted at end users. More often than not, it is targeted at developers. But again, for our projects, we don't really need to worry about that. Setup.hs, this is a file related to how Cabal builds things. Stack uses Cabal, remember. We use Stack, Stack uses Cabal. I've never had to edit this except maybe once. So if you're doing some more exotic things, you might need to change something in setup.hs. I've almost never had to use that ever. Source, this is where we keep a lot of things later. For now, we're going to keep everything in our main file, but in a real project would have our library code in source. So all of our type definitions, all of our modules and things like that, other than main, everything else goes in source. For us, we're putting everything in main right now. And remember, main is in app. App is a directory that has main. Stack.yaml is for Stack project level configuration versus the package level. So this is for like maybe more than one package, etc. We'll almost never have to touch this. When you do have to touch this, there will be an error message from Stack that tells you about it. It's when you need to use something outside of a well-defined package set. So Stack gets a lot of packages together. It has a list of them on Stackage, and it pulls down a list of these package sets that it knows they all work together, and it knows that which version of GHC they work with. So we don't have to worry about that. It makes our lives much easier. If we do go in there and have to add some overrides to that, say, oh, I know you don't know this package, but use this anyway, or use this version instead, that's where we do it, is in the stack.yaml file. But again, for our initial projects, we're not going to have to worry about that at all. The .lock file, stack.yaml.lock, this naming convention where we have another file name followed by .lock is fairly common. We check these into source control, and it's fine if you don't know what that means. What it's for is when we send it to other people, they use the same versions. It's to help ensure they use the same versions of the same packages that we used when we built it, so that the build works the same way for everyone, regardless of which machine they happen to be on. And the test directory is where we keep our tests, especially our unit tests. This is not something we're going to be doing for a while. As it turns out, testing is vital to software development, absolutely vital. We should always write unit tests. But when we're first learning to program, we don't know enough to write unit tests yet. So we have to first focus on learning to program. And after we learn to program, then we're going to learn to write unit tests, and we'll start writing unit tests for the stuff we practice with, that we develop. And so that's it for the overview. Again, you can forget everything I just said, except app is where main lives. That's all we really need to know at that point, is the app is where main lives. The rest of that's just an overview for curious folks, and to be kind of get you exposed to what's going on in there, so it's not a total shock to you later. All right, so now we need to change what's in our default main.hs, because it's not hello world. It prints some func. Hello world writes hello world to the screen. So let's open up that file. Remember, it's an app. It's main.hs with a capital M. .hs means it's a Haskell source file. Let me make this font larger, so if you're on a smaller screen, you have a better chance of being able to read it. Excuse me. So here we have our main, our module line. We don't need imports. So what I'm going to do is I'm going to focus on covering what to change first, and then I'm going to talk about what all these lines mean. So the first thing we do is we get rid of import lib. We don't need that at all, so just delete it. The next thing we do is we change some func here to, we change some func to put stir len with hello world. Now I'm going to talk about this a little bit more. So we want put stir len, and the S has to be capitalized. It has to have the same capitalization. So put capital S TR capital L N. Put string line is the mnemonic for that, followed by a space, and then a double quote, and that's really important. The double quote is really important. Hello world. It doesn't matter so much what you write here. And then the closing double quote is really important. So we have to have both double quotes, one on each end of this string. And this is something called a string literal. So you might take a minute just to review. We got rid of that import statement, and we changed what's after the equal sign in main to be put sterlen hello world as a string literal. And so you might take just a minute to make sure yours looks like mine, and then make sure we save it. You can pause the video or rewind it back to this to double check. And after it's saved, we're going to go back to our command prompt. We're going to type stack space run. And we see that it built things again. And we see it printed hello world instead of some func, and that's what we like. So I'm going to run it, and it's not going to rebuild it because I didn't change anything. So I'm just going to run it again, and we didn't get all the compiler output. Instead, we just saw hello world. So it's much easier to see that we got the result we wanted here, that we were expecting here. And so now hello world, the program, works as hello world, as expected. Now we're going to go over what this stuff means. And like before, some of you may not want this level of detail at this point. That is fine. I would encourage you to try and pay a little bit of attention. If it falls out of your head, that's fine. You don't have to worry about it. There's a lot of context we have to build up before this starts to really make sense. And so this is really just to satisfy the curiosity of people who are interested, but not for our learning so much right now. The exposure to it will be helpful later, though. The thing I want you to remember is out of this for the source, remember this video is about getting the program to compile and run, not understanding the program. So if all you can do is get it to run, it says hello world, you are successful. You're 100% successful. Great job. But I'm going to go for people who are curious, and I encourage others to try to pay attention a little bit, even though it may be confusing to this explanation. So the first line here tells the compiler it's going to be at the top of all of our files. It says, hey, this is a module, and the module is named main with a capital M because that's how we name our module. By convention, the main module is the one that has the program entry point in it, and that means the main function, and that's what runs when we run the program. Because later we're going to write programs with a lot of functions, and so the compiler has to know which function it has to start with. And so in Haskell, that's the main function in the main module. Now, our modules always start with a capital letter. Again, by convention, the compiler will happily let it be a different casing. We use a capital M though, or capital letter for all our modules. And again, by convention, the name of the module is the name of the file. So main.hs defines the module main inside of it, has the module main inside of it. The parent with some words and another parent, that's an export list. We could have more things here. We don't in this case. We just have main, and that's great. That's all we need. But we have the parents because we might have several things in there. And right now we're exporting the function main. And I know we haven't talked about functions yet. We will later. The function is down here, and that just says, hey, we can use main. Main is something that can be called from outside this module. Where is just a keyword to let the compiler know we're done with the module sort of information, and we're going to start defining the module. That's all this where means. So now we get to line 3, our next line. This is the type specification line for the function main. So we have just the function name main here. We have the double colon that says, hey, is type. We say main is of type, whatever follows after it. In Haskell, almost everything's a function, but the type operator doesn't only apply to functions. It can apply to other things as well. But especially up front, you're always going to see it here in this sort of line where we're defining the type of our function. The type of main is unfortunately complex for people new to Haskell and people new to programming. So it's we'll get there eventually, but what I want you to know, we read this as IO of type unit. So the unit type means there's only one thing it can return, so it's generally safe to ignore it. IO means we do input and output. So the takeaway here is if a function says IO, it does input and output, or it calls another function that does input and output. And so we have to always capture that input and output in the return type of our function. That's how Haskell manages input and output in a purely functional way, is with this type, this IO return type. We're almost never going to have to like make our own there. And even when we do, it's really easy. Excuse me. So now this last line here is where we define our function. This equal sign is not assignment. So this is our function name equals, and then here's our function body or function definition. You'll see this called an equation and the compiler error output. So please don't be confused by that. It's just talking about all of this thing here. I think I mentioned already, but if you're familiar with other programming language, this is not a variable and this is not assignment. It looks like that, but that's not what it really means. Putstrlen, as we already said, is a function that puts a string to the a string line to the console to standard output. And so we call that function. It takes a single argument of the type string. And here that type is, the value of that string is a string literal hello world. So it's all there is to it. Because Putstrlen has the same return type we want, Putstrlen has a return type of IO unit, IO of unit. We don't have to do anything else. There's nothing else we have to do. It's all very compatible. It all works. Now, when we program, we often take functions that call other functions. We write a function, and that function calls other functions, and that function calls other functions. That's just how programming has worked since functions have been invented and properly implemented in computer programming languages. So this is very, very normal that a function calls a function, calls a function, calls a function. So what we strive to do is make each function small and cohesive is the real word for it, but really on target, really to the point, and only does one thing, one function, one thing, that sort of idea. And that's it for our quick overview. Again, the purpose of this video is really to learn how to make a new project, get our tools installed, make a new project and run the project and start to get familiar with how to edit source. So that overview, if it didn't make much sense to you, don't worry about it at all. We'll build that up later in coming videos. Now, what I would do if I were you, what I do when I'm learning a new language, right after I get hello world, is I change it. Can I change it? What can I change? What does this mean? Because I know what it looks like to have it right. So can I change the string? Indeed, I can change the string. And so I'm going to do stack run again. We're going to see it rebuilds it, and we see hello Charles. I want to call out a common mistake. We change it back. We put it back to where it was. This time I'm not saving it. And you cannot save a file accidentally all the time. Stack run, and we see it did not compile, and we still see hello Charles, but in our source file it says hello world. So before we think, oh my gosh, I am crazy, and you might think that, I occasionally do still, and I've been in software engineering for decades. Let's save the file. Let's make sure the file is saved. And in Emacs, the 2 stars here mean it's not saved. So I'm going to save that. We see the 2 stars disappeared. If you have multiple files open, you might want to just save all the files or whatnot, check on all of them. Different editors have different ways to do that. So you're going to just figure it out on the editor you're in. It should have some documentation, certainly, to save it. Usually Control S would do it. So now we hit Control stack run again. Oh, you see it did build it this time because the file changed. And it printed hello world as we expected. There's some other changes we can make, and I'll let you go and experiment with it on your own to see how this works. For one thing, the white space isn't terribly significant in Haskell. It is in some places, it isn't in others, but you can hit a hard return here. And in fact, if we had multiple lines in this function, we would put them down, would line them up underneath the function name like this, just so it looks neater, so it's easier to read. And I'll show you, we could just go ahead and run that again. And I want to show you an error message, another common mistake, other than not saving it. Probably the most common mistake is going to be, I forgot to terminate my string literal. Terminate meaning end it with a double quote. So it starts with an opening double quote, and you see that the editor is smart enough to say, no, something's wrong here. It colored it different. So I'm going to go ahead and run it. And it says, oh, there's an error. I don't know what this means. And you have to get kind of far along. One of the not awesome things about the GHC compiler is its error messages are not super friendly for people who aren't already programmers. This will, after you learn a bunch of stuff, make perfect sense. But for now, I know it's gibberish. And in fact, half the time, it doesn't even matter what compiler I'm working on. Half the time, I look at the line number, and if it gives me a caret to look at, so I know what it thinks is wrong, I'll look there. And I'll also look at the line below it. So in this case, there's nothing below it. We've got the line above it, and oh, my string literal only starts with a double quote. It doesn't end with a double quote, and that's what that arrow is pointing at. So let me just add that back, because that needs to be there. It's very important to have both quotes around your string literal, and you see it works now. The error message gets worse if we forget both our double quotes. If we write this, because this is completely invalid in Haskell, it thinks that this is a function and this is a function, and that bang is something different. So we're going to stack run it, and we're going to get a harder to understand error message because it's so wrong. It does say parse error, or I can't tell, incorrect indentation, mismatched braces or brackets. It doesn't make any sense. So let's look at the line number, because we always look at the line number first. It says it's on line 6. Well, there's no line 6 here. There's nothing on line 6. That's fine. What that means is the compiler read everything here. It got to line 6 and tried to keep reading stuff because it didn't make sense. And said, I don't know what any of this means because it stopped before I got enough to figure it out. And that's because it's completely wrong. And that's okay. Remember, compiler error messages are bugs that the compiler has found for us. And that's where we go to we look back up, we see line 5. I forgot my double quotes. I'm going to add them back. So the compiler found my bug. In fact, it was such a bad bug, the compiler couldn't even compile it. So that's fine. We save that and we can run it again. And it works now. So that's good. So I'd encourage you to make several changes, just kind of experiment, see what you can do, get the hang of where whitespace works, where it doesn't, maybe interact with those error messages some to kind of get the feel for what's going to happen when it does happen. All right, so let's quickly review what we talked about. Again, we looked at our tools. GHC up is going to install everything for us. GHC is a compiler we're using, the Glasgow Haskell compiler. Stack is the project management tool, and we're going to be using Stack to make our projects and build our projects and run our projects. Stack uses Cabal under the hood, so if you see Cabal files, that's why. We installed everything. We learned how to run a project. We learned how to make a new project. We edited, we reviewed quickly some of the files that the Stack generated for us. We wrote our program. We changed an existing file to be the Hello World main from the default Stack template file to Hello World to have that behavior, to have the behavior of Hello World instead of what it was beforehand. Then we made some changes and looked at some error messages. And that is it for this video. As always, questions and comments are welcome. Thank you for watching. Please click like and subscribe, and I hope you have a wonderful day.